Hello professors, and welcome to the demo for Defense of Legends. In this segment, we'll be going through the setup on how to run the game. First, from the executable folder, launch the server.exe. Once prompted for the IP address, enter a 0, which is a shortcut for the loopback IP. Once the server is up and listening, follow by launching toclient.exe. In the same way, enter a 0 for the loopback IP. When prompted for a name, enter the name the player wishes to have. Defense of the Legends is able to host more than 2 people in a single game, but for the submission, we have limited it to a maximum of 2. Once all clients are connected, on any of the client's command prompt, enter the command /start to begin the game. In this segment, we will be showcasing our game idea. Defense of Legends is a game of the MOBA genre, MOBA being Multiplayer Online Battle Arena. In Defense of Legends, teams are split into red and blue. A team consists of players, minions, and towers. A player is represented by a blue cat on the blue team and a red rabbit on the red team. The goal of the game is to destroy all towers on the opposing team. At set intervals, towers spawn minions which pass towards and attack enemy players, minions, or towers. Players are able to click on any enemy target they wish to attack. While developing the game, we have implemented various AI to make the game feel more alive. Minions have basic pathing capabilities and steering behavior to avoid bumping into one another, while also constantly looking for the next closest target to attack. As for towers, they have a fixed attack radius that causes it to attack any enemy entity that steps within range. And that concludes the basic gameplay of Defense of Legends. This next segment, we will be showcasing our lag compensation mechanisms. To do so, we are using the clumsy tool with a lag setting of 500 milliseconds. The 3 checkboxes in our game to toggle these mechanisms are displayed at the top of the viewport. The first one, CSP, stands for Client-Side Prediction, followed by SR, Server Reconciliation, and lastly, EI, Entity Interpolation. As you can see, with all mechanisms active, the player runs smoothly for both the local client and the receiving client, albeit with a 500 millisecond delay. When Entity Interpolation is turned off, notice that there is a teleportation effect on the receiving client on the right, representing the player of the client on the left. Now, when Server Reconciliation is turned off, notice a rubber banding effect on the client on the left. And when Client-Side Prediction is turned off, the player comes to a crawl as he now has to wait 500 milliseconds for the next update by the server. This concludes the lag compensation mechanisms showcase. Please enjoy the next few moments of additional footage. We will now show a side-by-side comparison of the game played with and without certain lag compensation mechanisms. A lag delay of 500 milliseconds would render most competitive games unplayable, as it will be hard to depict to the player a fair representation of the current game state. In the demo we are seeing, notice that the bullets appear to freeze on even the client with lag compensation turned on. This is because within the duration of 500 milliseconds, bullets have been created and destroyed before the client is made aware. Other than that, the most noticeable difference is that the demo without lag compensation mechanisms come to a grinding halt, and is almost unplayable as entities freeze and teleport rampantly. Whereas with lag compensation, entities are still represented to move smoothly and accurately through with a slight delay and an outdated game state. Please enjoy and scrutinize the difference that lag compensation makes in Defense of Legends. In the last segment, we will be going through the code for the various lag compensation mechanisms implemented in Defense of Legends. First off, Client-Side Prediction. In Client Process CPP, which is the update loop for the client process of the game, notice the function here, Update Client. In Update Client, with Client-Side Prediction turned on, we update and set the position on the client side without having to wait for a response from the server. And if client-side prediction is turned off, we instead send the position to the server and wait for validation before updating the client position upon syncing. To implement server reconciliation, we added a sequence number to an entity object which is incremented every update on the client side. When syncing entities from the server, if it is a player, we first check the incoming sequence for outdatedness before syncing. Here, it is also where the server can respond with any issues regarding validation errors of the player. Lastly, we implemented entity interpolation in sfmrwrapper.cpp. Incoming server positions are stored in entity X and Y, while current positions on the client side are stored as interpolated X and Y. Every update step, an entity will be interpolated linearly along the direction calculated by the start and end. And that concludes our showcase of Defense of Legends, a multiplayer game developed in C++ using the Winsock library. Thank you for watching.